Hi everybody, I'm Adam, and this is Ying, and we work with Bosch here in Pittsburgh. And so for this talk, these are our goals. We were kind of hoping to discuss cloud portability as a topic that I actually don't see addressed here at SATURN very much, and I think probably could use more coverage in general. This is definitely an experience report. We want to give a description of how we approach this topic, this issue from the trenches, and it's kind of going to be kind of a journey from how we started with a monolithic app and through kind of a microservices type approach, and then finally culminating in how we did this port from AWS to Azure. And really for us, the central theme throughout all of this is we really want to take an agile approach. So we're agilists. We really live the agile kind of credo day to day. And so for us, what that means is we're balancing the need to provide iterative improvements in each sprint, with the needs of doing the refactor of the architecture. And then I'd like to also spark discussion. So please ask questions, and you're even welcome to interrupt me with questions if you like. Okay, so so I guess in some of the other talks today and yesterday, I saw a theme of how do you, around technical debt, how do you convince product management and product owners that you need to address some of this and do some refactoring. So the way that I've presented this in the past that had some success was to really talk about this as an airplane. So our product is an airplane, and really what we're trying to do is we want to know how do we fix this while we're flying. We have deadlines and bugs chasing from behind. We're chasing after new features, new customers, revenue, and there's this pesky wing needs refactoring. And so the goal is to upgrade the engine, fix this Band-Aid while staying in the air and getting to the destination. And this is really a diagram that really, in my experience, was able to convince people that, okay, we need to work on this refactor topic. Okay, so an outline, very high-level outline. We want to talk about the application in general, just give you a flavor for what the application has. Then talk about the initial architecture, how we then went about decomposing the monolith, and then we had this new requirement of being compatible with another cloud. And so then how do we do this migration, and how are we kind of continuing to move closer and closer towards being cloud agnostic? Okay, so the application itself is called In-Store Analytics, and this is a product where we deploy surveillance cameras, IP-based cameras, into retailers' brick-and-mortar stores. What the cameras do is they have the ability to detect and track people throughout a scene, throughout a field of view of the camera, and so there may be 10, 20, 30 of these cameras in a big box store, for instance. These cameras are able to send anonymized metadata to the cloud, and then what we do is in the cloud we will summarize the data, also do some corrections for false positives and false negatives, and then we produce summary statistics via web dashboards to the customers. This is, in case you're not familiar with this area, this is a big need for brick and mortar stores just because of the increasing pressure and competition from online retailers. And so here's an example of some of the dashboards that the customers want to see. They want to know, is this a laser? They want to know, are customers in the store engaging with different areas in the store? And so what the user interface allows you to do is you get a floor plan and you're able to draw shapes on the floor plan, and then you get different statistics like this about how much time people are spending there. Store owners also want to know, where do people flow through the store? This is really important for where they place merchandise, and they want to know checkout line length. So for example, if you have a checkout queue here, we want to automatically determine how many people are in line, and make tough calls such as, our edge cases such as, is that person in line, and that kind of thing. Okay, so the initial implementation for this product, so the background here is this was really kind of a new product for us, and I would say it's a nascent market. The market's not well developed, there's not clear leaders yet. I would say nobody's doing this very well yet, and so everything was kind of wide open, but it was also quite challenging. We had a small agile team. This is kind of an internal startup where we had to build kind of a large number of features in a short amount of time. And so I would try to relate this back to some of the discussions we've seen this week about, if you're building an application, do you start with monolith first or do you start with microservices first? For us, I have some quotes here from some of the blogs and stuff that we referred to here. But for us, really, we didn't really know what the application was going to be. We had an idea of what customers would want to see, but before launch date, we really didn't know what the real features were going to be. And if we had tried to design it, we would have gotten it wrong, to be honest with you, because we didn't really know what we were building yet. So this was really implemented as a single multi-tier monolith. We did have some operations previous experience to bootstrap us. Our parent project had some DevOps practices that we inherited and learned from. And we bootstrapped that DevOps code base from that project as well. But this also tied us to doing things the way they did in terms of ops, and so we really deployed everything to AWS, and we used several different AWS services, including EC2, RDS, and S3 heavily for dumping metadata from the cameras. And the constraint here is that actually each customer is getting its own set of cloud resources. So our DevOps game has to be pretty good here because every time we get a new customer and a new site, we need to deploy resources to make sure we can handle that extra load, and also build their whole website. Okay, so and then the limitations of this initial implementation were we had scalability issues with respect to the number of sites, also the number of processing components would not necessarily increase the performance of the scalability in that respect. And also different processing components require different amounts of resources, so it's not clear how to scale that. And from my perspective, actually one of the biggest issues was modifiability. So every time we were updating the processing logic, this would cause ripple effects in another part of the system. So the way that the system works, the metadata will dump data to an S3 bucket that's specified for this particular customer, and this kicks off a whole kind of processing pipeline of steps to generate the statistics and present them to the web interface. Okay, so now I want to talk about how did we then go ahead and kind of do our next phase of architecture here. And so as this application grew, we had more and more functional and non-functional requirements. We started to learn more about what this application was really going to be. The complexity started to rise, and I would say, at this time, to put it in the Martin Fowler's way of looking at this, the Agile team was really gaining knowledge about what the bounded contexts of the application were. So at this time, for us, this is where the light bulbs start to go off, where we start saying, okay, here's how we delineate the boundaries of these different services. And so at this point, we really thought it was time to refactor the architecture. And we kind of thought about, okay, how should we do this? We heard about this microservices thing, but we weren't really clear what it meant and what it meant to us. And so this is when we went and did some research about the topic. And the reason we wanted to take this kind of approach was we wanted to kind of achieve better maintainability and better modifiability. And get the scalability from it as well. And also what I like about it is to enforce vertical decomposition. And what really convinced us, to be honest, was coming to and doing a microservices tutorial here at SATURN. And what this convinced me was that it's not an all or nothing approach. It's really just a collection of design options that you have at your disposal. And so I describe this as a pragmatic approach towards microservices. And what I mean by that is a couple different things. First of all, the team can't just stop everything and re-implement the system. Because as I said, we have to keep the plane in the air, and you have to keep going towards your destination. We're a new growing product. We have to do more and more demos, try to get more and more customers interested. And so as a result of that, you have to implement all these architecture refactor changes iteratively while you're delivering value to the users. So at this point, we decided to buckle down and actually get more rigorous about our quality attributes. And so we define these as modifiability, performance, and scalability. For modifiability, we want to reduce the ripple effects. And the approach to solve that would be is basically to modularize the processing elements. We had a little bit of a situation where all the processing was done in one particular component, and what we realized is this application really needed to be multiple different components that were modular and were communicating by events. And so related to that, we want to be able to swap out processing elements so that we can do experiments about, can we improve one algorithm or the other. Typical performance metrics. And for scalability, we want to be able to scale to support new cameras, and then also we want to be able to add additional resources to decrease the amount of processing time for certain use cases, such as reprocessing large amounts of data. Okay, and so how did we do the decomposition? Well, pragmatically. And so on the left here, I have guidance from Martin Fowler's article on how to break the monolith into microservices. And then on the right, I have our pragmatic approach. And so the guidance here is to warm up with a fairly decoupled capability, minimize its dependency back to the monolith, decouple vertically, migrate in atomic and evolutionary steps. And the key quotes that I really like from this article are that this is really analogous to careful organ surgery. And the developers need to evaluate the cost of decoupling against the benefits. And so this is really, really close to what we kind of decided to do, I would say, separately on our own. And the way we were doing it, we decoupled the data processing components. And as I said, created a pipeline-based architecture here. What's important to me is actually in a project like this is to find a framework to help you, a framework that encapsulates the patterns that you're looking to implement. Because I think you get kind of double benefits out of this. You're not just getting the benefits of the patterns, and the patterns that we wanted was kind of like a pipeline-based data processing architecture. But in addition to that, you kind of get enforcement of those patterns. So we as developers, we all agree this is the framework we're using, here are the patterns we're using, and actually here's how you do it. And so we kind of constrain ourselves into this architecture, and it makes it easier. Otherwise, you'd have to go and invent different ways of having this pipeline architecture. Just if you're interested, specifically, we used Apache Camel for this, and this implements kind of the enterprise integration architecture patterns. And so the question is, okay, this gets to the point of, how do you peel? What do you decide to peel off first? How do you peel it off? So what we're trying to do here was, the first method for choosing something to break into a microservice is you figure out, okay, well, what's going to provide the most value in 1 to 2 increments, and that's a pretty good. That's a pretty good measure for what will provide you a benefit and still be able to deliver the features that you want to deliver in this particular sprint. And as everybody knows, I think if you deal with microservices, the hardest part is to get data autonomy from the system, because that's where the dependencies and the coupling between components actually really lies. Okay, so now Ying will talk about this one particular component as a example case.
Here is a concrete example of how we decompose this application into microservice. So mparser is the first component we separate out. So M here stands for micro. So this parser is actually responsible for extracting information from camera metadata and write it to positions files. The problem is when we have new change to the algorithm, or we want to change how we process the data, we need to reprocess a lot of data in a very short amount of time. For example, we have 1 month of data from one side, which have like 36,000 files, and in the past, it took like 85 minutes to process all these files. You can imagine when we have more size and more data, then it will take even longer than this. So speed up this process will bring high values to our customers. In addition, the M parser is actually doing it has only the single responsibility, and it doesn't have too much data to persist to the database. So we think this is a good component to be separate out. So the way we took is we break out the logic, the parsing logic, and put it into its own Spring Boot service. This service has its own data model and its own database. Also, we deploy this component independently. So after all this, we make it a microservice, and now for the same sets of files, and if we have 32 M parsers running in parallel, it only takes 2.5 minutes. This demonstrates that the microservice can scale linearly.
Okay, cool, thank you. Yeah, so this was the first service that we decided to peel away, and it was really good to do this performance test to convince ourselves and convince each other and convince product management that this approach makes sense and it's doable. And incidentally, we broke this out into what we called a microparser because we had this parser component that kept taking on more and more responsibilities, and so this is where we were getting the ripple effects that I was mentioning before. Okay, so now, basically, that was kind of like the first phase that we want to talk about, give you the background, our approach towards microservices, and then we want to talk about the cloud agnosticity part of this. Okay, so we're pretty proud of ourselves. We did this partial refactoring. Architecture's in a good state. I would say actually even team's working relationship became better. We had better communication. We understood what we were talking about. We had common architecture patterns. And now comes along a new requirement from our customers, actually. Customers want to deploy it to an arbitrary cloud. Some customers don't like Cloud A, they want Cloud B. Some customers want to deploy it to their own virtualized environments. And in this case, we had a customer who didn't want it to be deployed to AWS, they wanted it to be deployed to Azure. So in addition to this, we can see some other benefits as well. I mean, we had been kind of thinking this direction, but there wasn't a real reason to do it yet. But in the future, this is going to give us the ability to avoid vendor lock-in and also enable us to scale up and scale down by kind of forcing us to keep going further with our microservices architecture, I would say. Okay, so I think one of the first reactions in this day and age would be to say, okay, great, so now you're going for a containerized cloud-native architecture. But for us, we wanted to make sure we made the right decisions for the right reasons. So I guess the first question really here is, do you gradually try to go towards cloud agnosticity, or immediately go for it and just adopt containers altogether? So some benefits of using containers for us, we could get lower costs. Obviously, you could deploy multiple services in a lower number of nodes. You could get better scalability. But however, we think there's lots of drawbacks. And I think the scalability doesn't come for free, is what we're trying to say here. You basically could end up with, if you try to do like a lift and shift, you could end up with a containerized app that is containerized, but it's actually not more scalable. And actually, in our case, our application needs to handle out-of-order data. And really what this means is that we're not going to get this scalability for free without continuing down the path that we originally went down and continuing to kind of do this architecture refactoring to be more modular, to be more event-driven, to be more like microservices. And in the end, the database access is still going to be the bottleneck, so you have to attend to that issue. And I would say one of the more convincing arguments to me is that there's a huge learning curve for this approach. I don't know, was somebody calling this the microservice task or something, tax or something like that? It kind of reminds me of this as well, especially at the operations side. We have all this really nice DevOps code, and we have to kind of redo that and rethink how everything's working. And so in the end, it's really, is the effort versus payoff equation working? And so we actually find that Ying found this some evidence of other people agreeing with us that this is not a silver bullet. And again, the quote here is saying, if you can gain performance costs and other benefits, then you should go for it, but don't just do it just because it seems to be the flavor of the month. Okay, so as we're moving to a more of an event-driven architecture towards this data processing approach, where we have a pipeline architecture, we're going to use more and more messaging, and we were already using AWS SQS quite a bit. Basically, we use this feature of S3 where a camera can dump its metadata into an S3 bucket, and S3 has this cool feature where it will generate SQS messages as events when files arrive. I see cool because actually probably cooler for them because it'll choose you to use it and then you get locked into it. And as we decided that we wanted to break up the parsing components into more of a pipeline and have this be event-driven, we realized that actually SQS didn't have the perfect semantics for us, being kind of a request-response type pattern that you're going to get with a typical web API. You don't get a lot of the enterprise strength broker features that you get, and so we decided that we wanted to migrate towards an enterprise strength broker anyway. So now we're opening up a whole can of worms, right? We decided to do this. Somebody made one simple decision, and now we have to make all these other decisions that are related to it, and actually they spur us to want to make other decisions that seem to be increasing our work. So now we think, okay, we got to be really careful, make sure we take this slowly, make sure we make the right decisions. So getting back to the messaging topic here, there's a lot of options here for messaging these days, actually. Amazon has its own managed ActiveMQ service. Azure has Azure Service Bus. We could basically provision our own ActiveMQ or other type of broker, such as Kafka, to its own VM. And so the question is, how do we make this decision? And so basically, we wanted to enumerate and evaluate all the options, do a pro-con type of a table, and choose really the option that provides the ability to migrate quickly while preparing for this kind of cloud agnostic architecture that is really our goal right now, and while still being able to deliver new features sprint to sprint. And so this was, I think this conclusion's in the wrong spot, but so here's kind of a flavor for the options we were looking at. So we were looking at this decision in a couple different dimensions. So basically, you could just deploy a virtual machine with a new broker on it and have that be easily deployed to your two different clouds. Or you could decide to just go for more of a message interoperability type of approach where you look for different brokers that support the same wire protocol. This one was really appealing from a, I would say, conceptual point of view. I would love to live in a world where two different brokers speak the same wire protocol in the same way and you get the same results, but we had a really hard time believing that this was going to happen. And so in the end, what we really decided to go with was to do this, host our own ActiveMQ server on a virtual machine that can be easily deployed as the same component to two different clouds. Okay, so now Ying will talk about our object storage, because now we, as I mentioned, we use object storage very, I guess, widely here, and so we had to next thing we had to think about was, okay, how are we going to store these files in an agnostic way between two different cloud vendors?
Okay, thank you, Adam. And so after we migrate our message platform to ActiveMQ, the next one is object storage layer. As we mentioned, we rely heavily on S3. So we store and retrieve and list metadata files from S3. We also store images, and retrieving them will pre-assign URL with S3 specific features. So to move toward a cloud agnostic architecture, we have a couple of options to reflect that part of code. So one thing is we can either use Apache JClouds or some third-party translators, but the problem is they are either not sufficiently abstracted enough, or it might add another layer to break, and we might not know how to maintain or change the code. Another option is the CDMI, which is an ISO standard, but it's not implemented by public cloud vendors. So the approach we took is we define our own abstracted object storage interface, and we refactor our existing code to use the interface. The challenges we have along the way is we originally used a mix of Spring Cloud libraries with AWS SDK. We also, and some of the Spring Cloud features were hard to replicate for Azure. So the way we took it is we refactor the existing code, and we are trying to move away from features that is only available on S3. After we do that, we refactor the code. We're testing the code on existing AWS-based stack and make sure it's working. And then we take another sprint to implement the interface for Azure. It takes a couple of sprints for us to refactor testing, and also there's a learning curve of like Azure storage account and blob containers, but it pays off eventually, and this actually was a necessary refactoring to enable component decoupling and service autonomy.
So I just want to add one thing. I mean, so in our opinion, this is actually one of the hardest part of this migration, not because implementing this layer was so hard. I think it was relatively straightforward, but the problem is you're going to have to store files. This is kind of like a side effect, of your system. You're going to have to store files somewhere. So say you went to a fully containerized system. What are you going to do for object storage? You have to build your own container service that somehow replicates these object storage services, which have this unbelievably high availability and high durability. So for us, you're always going to have some kind of translation layer to write to object storage if you're using files heavily like this. So yeah, thanks.
Okay. So after we migrate make our applications to be cloud agnostic, so what happened to our infrastructure code? So we also adapt our infrastructure deployment code. So originally, our infrastructure code initiates cloud resources and provision VMs using Ansible. Ansible is a good tool for provisioning, but does not have good support of different vendors' API. For example, it has good support for AWS, but not for Azure. So the options we have is Terraform. So Terraform claims to be cloud agnostic, and it actually have a good support of different cloud vendors. The approach we take is we separate our infrastructure code into two layers. One layer is for create cloud resources, and another layer is to provisioning the VMs. For the cloud resource layers, we implement Azure code in Terraform. But for the AWS part, we keep it using Ansible as the first step. And for the provisioning layer, we use dynamic inventories and use VM tags, so we know which instance we want to deploy. So the tricky part is we still have some artifacts live in AWS world, so we need to have some operation workaround to make it happen. So to move forward, if we move to containers, we're thinking is provisioning code will go away. We can use Dockerfile to realize that. And for the cloud resource layer, the difference will be we'll have to manage containers instead of VMs.
I think this ended up being the biggest bulk of the work, right? The ops code?
Yes.
So in the end, the ops code is the biggest bulk of the work, because what we have now is a set of definitions for virtual machines in our in a combination of Ansible and Terraform that we can deploy to two different clouds, and so now it's relatively portable. But it was actually the building of the virtual machines and the different cloud resources in each cloud that was what took up, I would say, the bulk of the work. Now going forward, as we're saying here, maybe getting ahead of myself, but one of the downsides is all this code would go away if you were then to continue on and move towards containers. Is this our last one, or is this? Okay. Okay, cool. So from our opinion is we really took the right approach for this. We gradually moved towards cloud portability. It was really a stable migration. It was a little bit frustrating. There was the typical turns and unexpected issues that would come up, but the system stayed stable. One thing I didn't mention was accuracy is a huge benefit, a huge quality that we need to adhere to, and so we have nightly running jobs to make sure that all these changes don't result in some kind of non-deterministic output from some of our statistic collection. I'm really proud of the team for the way they took this kind of methodical, agile approach to the architecture refactoring. And there are some drawbacks, though, I would say. So if you do monolith first and you kind of rely on this metric of we will peel something away, we will refactor something as long as we can make it visible and valuable to the end user, I think you will always end up with some small part that has not been demonolithized. So at some point you might have to just finally decide to pay down that debt if you want to get rid of it. Because I would say our journey towards microservices is definitely not complete either. Okay, so for future work, we want to evaluate how or when to keep continuing this path down towards agnosticity, and does this involve containerization or not? We will continue the decoupling work, and as I mentioned, we need to focus on the data models and making the data autonomous and separated between the different services. Okay, thank you.